Okay, so welcome to the final session of this particular NPTEL course, Waste to Energy Conversion. So this is a kind of a summarizing session we have decided to organize. So here we'll discuss all the sample questions we have discussed uh, and the brief overviews of the contents which have been discussed throughout the course. So the first week was about the basics of the waste. So the different definitions of waste, their classification, uh, important quality parameters, different types of waste, what kind of wastes are suitable for energy production, solid waste, wastewaters, their detailed classification, those are there. Apart from that, basically the case studies like availability of different types of wastes, wastewater, and routes for solid waste management, the requirement of energy production from waste, and basic some case study scenarios and different routes of energy production from wastes. And then it followed the characterizations consisting of physical and chemical characterizations of solid waste, which included proximate and ultimate analysis, fusion point of ash, lignocellulosic composition, leaching properties, energy content, and also characterization of wastewater. Then we come to the questions. Hmm. So which of the following is not a quality parameter of solid waste? Elemental composition, heating value, bulk density, BOD and COD.
The BOD and COD.
So the correct answer is BOD and COD. So BOD and COD is the quality parameter of wastewater. This is not a quality parameter of solid waste. The rest of the things are the quality parameter of solid waste. Based on the source of occurrence of wastes, solid waste can be classified as municipal solid waste, industrial solid waste, agricultural waste, all of the above.
All of the above.
So basically, the correct answer is all of the above. So based on different classifications, these are all the types of uh, solid waste. So based on source, municipal solid waste, industrial waste, agricultural waste, these are classified. Similarly, based on the biodegradability, based on combustibility, based on compostability, usability, there are further classifications of solid waste which can be made. Can go back and check the original lecture slides. Which of the following is not a thermochemical conversion route for energy production from waste? Combustion, gasification, briquetting, pyrolysis.
Briquetting of biomass.
So the correct answer is briquetting of biomass. So it's not a thermochemical conversion route, it's a physical conversion route. Apart from that, the pyrolysis, combustion, gasification, liquefaction, these are all the thermochemical conversion routes. Find the most suitable option to match the following biomass conversion routes with their appropriate technologies. You have to match them, the biomass conversion routes with their appropriate technologies.
Option 1.
So yeah, so option one is the correct. So it's very simple. Thermochemical conversion is pyrolysis. Biological conversion is the anaerobic digestion. Solvent extraction is the chemical conversion, and briquetting of biomass is the physical conversion. Particle size of the solid waste can be analyzed by sieve analysis, trommels, particle size analyzer, all of the above.
All of the above.
So yeah, so sieve analysis, trommels, particle size analyzer, all of these can be used for the particle size determination. So in proximate analysis, the moisture percentage is measured by drying the sample at uh, what is the temperature and for how much time you have to tell.
Option 4, P is equal to 105, Q is 24 hours. Sir, option 4.
Yeah. So 105 degrees Celsius and 24 hours. We carry out the proximate analysis to get the moisture content. Similarly, for volatile matter, we take it at 950 degrees Celsius for 7 minutes. For ash content determination, we go for 750 degrees Celsius for half an hour in the presence of oxygen, and for fixed carbon, we do it by the subtraction. Okay. Uh, so lower heating value is determined by subtracting the heat of vaporization of water from the higher
High
heating
heating
value.
value. Mhm.
So, yeah. So
Option A.
this so higher heating value is the correct answer. You have to just subtract the heat of vaporization of water from the higher heating value to get the lower heating value. And so bomb calorimeter is the major instrument which we use for determination of this particular parameter. So a known amount of solid fuel is burnt in a bomb, and the generated heat is used to raise the temperature of the certain volume of water. And then from that we use the correlation like mcp delta t, and by that we measure the temperature increase, and we correlate it with the heating value of the particular material. Like the detailed calculation, these are available in the lecture slides. You might check it. Generally, with solution with a normality of 0.25 normal is used to determine the COD in wastewater. Sodium chloride, sodium hydroxide, potassium dichromate.
Dichromate, the third one, I'm sorry. I'm not the. Sir, I'm just guessing potassium dichromate maybe.
Yeah, so potassium dichromate is the correct answer, but you might check the basic concepts of these things. So the basics equation which is there for the COD determination. So it is used for the chemical oxygen demand calculation to, and the equation which is it follows, we get it by the amount of chromium ions we get and the amount of CO2 we get, and then uh, based on this particular stoichiometric calculation we get like the D, as I said, the chromium ion concentration. So D we calculate, and based on that the COD is determined. So most commonly 0.25 normal solution of potassium dichromate is used for COD determination. Okay. So
Sir, if I may ask a question, is it appropriate to ask? Or
yeah, yeah.
so actually, I have opted for this test, which is scheduled day after tomorrow, and I was just curious if we can get the access to, like, the last 5 years papers. What is the pattern? Is it going to be the same, like, option wise, like, we'll be given the options and we need to choose one, or how is going to be the exam pattern? I have never given any
So
exam like this in
I,
before, so
so I don't know because we are also don't have this kind of access to last 5 years question or like that. So
okay.
whatever questions I have discussed in like I think there are two ATAs we are here in this particular course. So you can check the videos of the eight lectures.
Mm-hmm.
Okay. So these are all like for the last year sample assignment type the kind of questions.
Okay.
So in these assignment questions, there are options, but in the as far as I know, they are in the original like online exam. So there will be some like this kind of MCQs, and
Mm-hmm.
apart from that, I think there might be something you might have to give your values like numerical things, and might have to give a kind of MSQ type of thing like.
Mm-hmm. So for the multiple choice questions, there will be options given, but even for the questions wherein, like, we will need to run some formula and get the answers, options will be given. We need to choose one of those answers out of those, right? Something of
Yeah,
that
and
sort.
also you might have to enter, some writing or something. Those kind of questions might also be
Description,
there. Yeah,
descriptive answers.
descriptive
Okay.
type might
Okay,
be.
sir.
But
Okay.
majorly, what I understood and what I suggest strongly, you please check the like as much as you can the numerical things
Mm-hmm.
for for the all the lectures. Okay, so that those type of questions actually what fetch you the marks, and those actually carry a large chunk of number marks.
Okay. Weightage is given more to those questions. Okay. Understood.
Yeah,
Rather than the
usually.
theory.
Hmm.
Okay. Okay, sir. Yeah.
Because
And do we
theory
have
there is
all those
no.
video recordings available? I'm so sorry. I missed all of those earlier. So,
Those are all available in the YouTube.
Asha.
I think you guys have like the link. There is one Excel sheet link, Google
Mm-hmm.
sheet. There,
Asha, so
all the
there are those.
YouTube links are there. Yeah,
Mm-hmm. Understood.
these live sessions. So this particular session, I'll be just quickly going through the questions which we have discussed.
Mm-hmm.
So like if you have, you should go and check the original videos. The exam is not very far, so I don't know how much you can cover, but you can check those. Okay.
Understood, sir. Thank you so much. Yeah.
Yeah.
And are we recording this session as well?
Yeah. Yeah. Yeah.
Okay, great. Thank you, sir. Yeah.
Okay. So moving ahead, the atomic absorption spectrophotometer works on the principle of.
Lambert Beer law.
Yeah. So BLMS law is the correct answer, based on which the AS instrument works on. So just put an sample curve here for the BLMS law, how the calibration is done. So at different concentration, we measure the absorbance, and then based on that, we calibrate our sample, and then ultimately we get our measurement. Then this is one bomb calorimeter based numerical problem. Solid waste with 1% sulfur is combusted in a bomb calorimeter. Temperature of the bucket water increases from 25 to 28 degrees Celsius. The water equivalent of the calorimeter is 2402 calorie per centigrade. 1 gram sample used, par 445 C10 wire is used, uh, and 2.6 centimeter of wire out of 10 centimeter of wire is unused. So we have to calculate the gross calorific value.
So I recall the formula something like the uh, the right side of the equation is going to be this equivalent water equivalent multiplied by the degrees rise 25 28 minus 25 is 3, so 2403 multiplied by 3 minus E1 E2 minus E2 minus E3. E1 would be our titrate required, which is 24.2 ml multiplied by 1 calorie per ml for the sodium carbonate, minus the 13.7 times the concentration of sulfur, which is 1%, and the sample weight is specified as well, right? So we will multiply that with the sample weight,
Yeah, it's 1
and
gram.
1 gram, yeah, and that minus the uh, since this is 26, yeah, this is par 45C 10 wire used, so it will be 2.3 multiplied by 10, sorry, multiplied by 7.4, because that is the, sorry, 2 points, yeah, 7.4 is used up, right? So 7.4 multiplied by 2.3, all of it divided by that 1 gram of the sample, and whatever number comes out.
Yeah. So yeah. Uh, so that is a basically putting it in a simple way. There are this kind of like three parameters C1, C2, C3. From
Hmm.
them, you have to get the E1, E2, and E3 values and just put them in this particular formula. M is 1 gram, as you mentioned. The delta T is 3, and the similar things. Yeah. Okay. Then the second week lectures. Second week, so like the tutorial on characterization of waste. So I think this is also a similar kind of question to now have to determine the water equivalent, which just simple mathematics, just LHS, RHS things. So the same formula you have to just, you know, the temperature now goes below and the water equivalent comes in the left hand side like that. You you get the water equivalent by the similar kind of formula. Hmm. Then one question was discussed based on the for the proximate analysis. So this kind of like question looks very much weird and very big, but it's a very simple one because they have just given the methods to determine the different properties of the material, moisture
So
content,
option
VM
C
content.
seems to be the correct answer, just looking at the numbers. Moisture 20 and volatile matter 40.
Yeah. So as I told, it's just looking by like elimination method, you can actually get the actual answer. But in examination, this kind of simple problems might not be MCQ. I don't know. Might be you have to type it. So you have to be very careful. So the COD determination, one problem on COD determination was also discussed. Hmm.
I think there is a formula here which I don't remember on the top of my head right now. And unfortunately, there is so much formula
Formula
based.
is COD calculation is 8000 into blank minus sample divided by sample volume
Oh, wow. That is very easy. 8,000 minus in this
into
case will
B
be
minus S. That is blank minus
20
sample.
then. Yeah. Uh-huh.
Yeah.
Divided by 150 ml of the sample. Okay.
Normality divided by sample volume, that is 150 ml it is given.
Mm-hmm.
Blank is 75 minus 55
Yeah.
into normality is n by 10, that is 0.1. Am I correct,
Okay.
sir?
Yeah. So 8,000 into
Yeah.
75 minus 55 into 0.1 by 150. Yeah, this is actually very pretty like simple formula. You might just check once. Yeah. And then some basics of like incineration was covered. So incineration has this kind of contents like its mechanism, air requirement, different performance factors, advantages, disadvantages. So you might not be like required to like memorize each and everything blindly. Just to get the crux of them, just the concept, and use your head while trying to answer, because there is a lot of theoretical things I understand. So it's difficult to memorize each and everything, each and every, and usually the questions comes by this particular point of view, that how much of the concepts you have grasped. Okay, so obviously dash is a waste treatment process which involves the combustion of organic substances present in the waste materials. Incineration, drying, briquetting, all of the above.
The incineration, combustion of the organic substances.
Yeah. So obviously drying and briquetting cannot is not possible. It's not a combustion process. So incineration, which involves the combustion of organic substances. Then next question is, combustion is the sequence of which kind of reactions between the substrate and oxidant, which is accompanied by,
Exothermic chemical.
yeah. So again, very straightforward. Like production of heat is there, so obviously it will be a exothermic chemical reactions. The correct sequence of the steps involved in the mechanism of combustion is,
The second one, the drying.
A.
why do you think like one is saying A, one is saying B?
I think the volatile matter will. Okay, but I could be wrong because the solid char is happening at the end. So I think Sheetal ma'am is correct. Drying followed by the reduction followed by the combustion. That makes sense to me as well. Yes.
Yeah. So obviously first the heating and drying would be there, then the pyrolysis. So usually what happens is pyrolysis and reduction, these are, pyrolysis is itself a very vast process. So usually what happens is there is a low temperature pyrolysis which is also called torrefaction. So this is used as a pre-treatment. So in the absence of any kind of oxidizing atmosphere, when you go for this low temperature pyrolysis, then there's kind of volatile, some volatile matters will come out like CO, CO2, these kind of light hydrocarbons. These will go out, and then we go for the combustion. Which of the following is not a type of fixed bed combustion system?
The circulating fluidized bed one.
C. C. C.
Yeah. So circulating fluidized bed. obviously is not a type of fixed bed combustion system. Which of the following is not a type of great firing combustion system?
D. Last.
Yeah. So vertical grades is not a type of the great firing combustion system. On the other hand, the types involved, the fixed grades, moving grades, rotating grades, these are actually the types of the great firing system. Uh, Another small numerical, the composition of flue gas from an incinerator is given. You have to calculate the weight ratio of hydrogen to carbon in the waste. So basically the correct answer would be 0.2. So if you take 100 moles of dry flue gas as basis, the CO2, oxygen, these are given, the rest is nitrogen. So from that you can get actually the, if 84% is the nitrogen, so by back calculation, taking as 79% nitrogen available in the air, you can get the oxygen available with the supplied air, because nitrogen is inert, so it will not go any undergo any reaction. So, and the flue gas we are getting 5.5 moles of oxygen. So rest of the oxygen is consumed to 22.33 minus 5.5 is the oxygen consumed, and then just go for the simple mass balance. So C plus O2 CO2, 2H2 plus O2 2H2O. This would be the two reactions. So just simply moles calculation, and from that the weight of hydrogen in waste and weight of carbon in waste you can calculate, and then the ratio, simple form. Okay, then after that the gasification technology was discussed, basic definition and basic chemistry of gasification, its reaction schemes and steps, types of gasifiers, advantages of gasification, typical process flow sheet and utilization schemes, and then gas especially for different gasifiers for biomass and waste, advanced process and comparison between incineration and gasification. So let's see some questions. Fischer-Tropsch synthesis is used mainly to convert syngas into
All of the above.
so basically the correct answer would be liquid fuels. So Fischer-Tropsch synthesis specifically is used to convert the syngas into different liquid fuels like diesel and gasoline. In the gasification process, when air is used in place of oxygen, the produced gas contains a high amount of nitrogen, sulfur, hydrogen, oxygen.
Sir, nitrogen. Sir, as we speak, I was actually looking at that Swayam portal, and I'm not sure where exactly do I find that the videos of the tutorials that were done earlier. Maybe can I connect with you separately because I'm taking up time of the other candidates as well who are on the call right now,
Mhm.
or if you could guide me in the interest of time, maybe after this session is over, or you
I'll
can do
just
that now.
put
Yeah.
it in
Okay.
the chat box. Okay.
Okay, sir. Yeah. Thank you. Looks like the chat has been disabled from my end.
You can't see the chat box?
No, sir. Maybe because I'm logged in through my company's account. They have disabled it, I guess.
Okay. Uh, is the chat box visible to everyone else or is it for everyone this problem?
Same problem with me also.
Okay. There might be
I
some
have given
setting.
two answers in the chat box, but I think they are not visible to everyone.
Okay. See it.
So anyhow, as we speak, I actually found one link when I logged into my account. If I go to the very bottom
Mhm.
of the menu bar on the left, there is this after
Okay,
one week one, two,
I
three
get
last
it. I think
I found it there. Yeah,
there is the announcement section na,
correct,
for the
correct, correct.
NPTEL
Somewhere there.
course.
Yes,
Yeah,
yes, I found it.
yeah,
Yeah, yeah. Thank you, and sorry for the disturbance. Yeah, please continue.
yeah. No issues. Okay, so the correct answer is nitrogen. And air is used in place of oxygen. The produced gas contains a high amount of nitrogen. Then we move to the third week discussions. It is the gasification which is being continued. Uh, Fixed bed gasifier used for gasification of coal and pet coke requires a retention time of how many minutes? So the correct answer is 15 to 30 minutes. The typical retention time for a fixed bed gasifier. For fluidized bed gasifier, it is lesser. And then for entrant bed, it's further lesser. Okay, in the seconds. The pressure required for gasification of coal and pet coke in entrant bed gasifier is in the range of how much megapascal?
So I guess option three, almost like 3 seconds around, uh, 2.94 to 3.43. So I see you have got somewhere around 188 slides, and we are almost close to 1 hour. If we can, like, speed up the discussions. I understand this is very informative, but we can cover
Yeah,
as much as possible during this call. Yeah,
yeah. Okay.
thank you.
So yeah, the correct answer is it's around 3 megapascal. So 2.94 to 3.43 megapascal. So overall water gas shift reaction can be represented as, so the reaction is same. You have to tell basically the delta based on the delta H values. So the correct answer is the delta H0 is minus 41.1 kilojoule per mole, and obviously the water gas shift reaction is CO plus H2O gives H2 plus CO2. Then the further lectures included the syngas utilization. So different syngas utilization options, cooling and conditioning methods, and some important utilization techniques like Fischer-Tropsch synthesis, methanol synthesis, DME, higher alcohol synthesis, hydrogen, like that. The liquid products formed from syngas in Fischer-Tropsch synthesis is wax, naphtha, diesel, all of the above. So correct answer is all of the above. So wax, naphtha, diesel, these are all the liquid products which can be formed by the Fischer-Tropsch synthesis. The overall Fischer-Tropsch synthesis reaction is it exothermic or endothermic, and what will be the enthalpy of reaction? So it's a exothermic reaction, and the enthalpy of reaction is minus 180 kilojoule per mole. The methanol synthesis from CO2 and hydrogen is usually achieved over what kind of catalysts? Zinc and alumina, copper and zinc oxides, nickel and iron oxide, none of the above.
Option B, copper and zinc oxide.
Yeah. So copper, zinc, alumina. Basically, this is the common catalyst for methanol synthesis from CO2 and CO2 hydrogenation. Then pyrolysis was discussed. Definition of pyrolysis, its mechanism, types of pyrolysis, its operating conditions, uh, the utilization of pyrolysis products, uh, and then the catalytic pyrolysis, and obviously the pyrolysis product like bio oil and its upgradation techniques, different reactors, and the char and gases utilization, which we get after pyrolysis. So this is a common question. So pyrolysis is basically a thermochemical process which converts the different types of biomass and organic waste by application of heat and in the absence of oxygen. Okay. Pyrolysis is the only thermochemical process which converts different types of biomass and organic waste into solid, liquid, gas.
All of the above. Uh, so my suggestion is, in the interest of time, if we can, instead of waiting for us to give the responses, if we can quickly move through, is that an appropriate approach?
Yeah, don't worry, we'll cover all these things.
Okay, thank you.
So all of the above would be the correct answer for the pyrolysis reaction. So you have to identify this type of pyrolysis reactor presented in the schematic diagram. So it's a type of a circulating fluidized bed type of pyrolysis reactor. The biochar produced in the pyrolysis of biomass and waste can be used as solid fuels, fertilizer, adsorbent, or all of the above. So biochar can be used mm, as a solid fuel. It can be used as fertilizer and as well as adsorbent. Then we come to the fourth week, a numerical problem. So in an MSW gasifier, the air flow rate and feed flow rate is given. The MSW does not contain any sulfur, nitrogen, or chloride. The syngas composition is provided. You have to calculate the rate of production of syngas in normal meter cube per kg of MSW. So it's again a simple thing. The formula, if you go by it, the rate of production of syngas is equals to the air flow rate into 0.79 divided by 1 minus the summation of all the gases and multiplied by the feed rate. You have to just put the values. Air flow rate is 10, feed rate is 8, and these syngas composition things are given here. So you get the rate of production of syngas. Now a question of bio oil production. Pine needle is used to produce bio oil in a slow pyrolysis unit. Percentage of bio oil, char and gas is given. and average molecular formula of biochar is also given. So I have to calculate the percentage of carbon converted to bio-oil, and also the composition of the gas is also provided. So if we take 100 gram of pine needle as basis, so it's 40 gram bio-oil, 45 grams biochar, and 15 grams of gas is there. And bio-oil molecular formula is given. You can get the molecular weight from it. So you can basically get the how much bio-oil is produced in terms of moles. And the similar way, you can get the biochar uh, molecular weight as well. The for the biochar molecular formula is given, and similarly biochar formation in terms of moles is also you can get, and the same thing in for the gas also. Okay, because the gas composition is also given, and then just go for the calculation. The carbon present in bio oil you'll get it because the composition similar with biochar gas, total carbon you get, and just percentage of carbon, it is the carbon present in bio oil divided by the total carbon. Which of the following statement is not true about densification? It provides simple mechanical handling and feeding. It provides uniform combustion in boiler. It reduces the cost of transportation. It increases the dust production. So basically, uh, the incorrect statement is the it increases dust production. Basically, because densification actually reduces the dust production. All of the others are the correct because these are the advantages of densification. The most important factor in the binding process of biomass densification are moisture content, bulk density, thermal properties, all of the above. So all of the above is the correct answer. These are the all physical properties. These are all most important factors in the binding process of biomass densification. Based on compaction, the types of briquetting technologies are high pressure compaction, low pressure compaction with a binder, medium pressure with a heating device, all of the above. So these are all the types of briquetting technologies. So all of the above will be the correct answer. Mechanical piston presses and pellet presses make briquettes with density in the range of uh, what is the density in kg per meter cube. So 1200 to 1400 kg per meter cube is the correct answer. Friability index value of dash indicates the briquettes disintegrated entirely after a certain time. 1, 2, 0, 10. So friability index 0, it indicates that the briquettes are disintegrated entirely after a certain time, which indicates the inadequate briquette quality. This is a numerical problem for the compaction. A 10-ton hydraulic jack was used to lift the machine components and compress the briquettes. The compaction force can be calculated using pressure. Pressure reading from the pressure gauge connected to the hydraulic jack is 17.5 kilonewton per meter square, and the machine has 30 molds, and the diameter of the briquette sample is 25 millimeters. So you have to calculate the compaction force. So compaction force equals to the pressure into total compacted area. Pressure is given 17.5 kilonewton per meter square. Total compacted area will be the number of briquettes produced at a time multiplied by cross-sectional area of briquette. So cross-sectional area would be pi d square by 4. Number of briquettes is 30. 30 moles is given. So you just put the values and get the compaction force. Will be 257 Newton. The overall high energy production from a waste to energy plant depends upon heating value of the waste, thermal efficiency of the boiler, efficiency of the turbine generator, all of the above. So all of the above will be the correct answer. So the overall energy production from a waste to energy facility, it depends upon these are all the important factors: heating value of the waste, thermal efficiency of boiler, turbine generator efficiency as well. The thermal efficiency of waste to energy power plant can be expressed as
Answer B.
yeah. So thermal efficiency equals to energy generated into time divided by the MC into CV. MC equals to the quantity of fuel per unit of heat consumed, and CV is the calorific value. Then we come to the fifth week lectures. Fifth lecture discuss the power generation flow sheet, performance of waste-based power plant, the different factors influencing power efficiency, thermodynamic cycles for power generation, cogeneration and heat recovery, overall plant efficiency, energy analysis of the boiler, and different types of turbines, their cycle, power generation cycles, working of combined cycle and efficiency improvement, efficiency calculation through thermodynamic laws. Useful energy indicates the energy available in the produced steam, which depends on steam generation rate, waste or fuel burning rate, temperature and pressure of the steam, all of the above. So all of the above is the correct answer. So useful energy indicates the uh, energy available in the produce stream that depends on the, these are all important factors which depends on. Useful energy of the steam process can be calculated by, these are the four options. So the correct answer is useful energy equals to high rating value minus energy losses. And then the plastics, the uh, plastics conversion, plastics, their classifications, their monomers, plastic waste generation, it needs proper management, plastic waste management and recycling through pyrolysis, and then further the pyrolysis detailing, reactors for pyrolysis, process flow sheet, and some case studies, international and national scenario on this. These are discussed. Lunch boxes, margarine containers, yogurt pots, syrup bottles, plastic bottle cap, prescription bottles are typical examples of products which can be produced from.
Option B.
So yeah, polypropylene is the correct answer, and these are the other types of examples, and they are typical types of the plastics. You have to match the following with the type of plastic and their monomer. So it's very straightforward question. Polyethylene, low density polyethylene. By the name you can identify which monomer would be ethylene, polypropylene monomer will be propylene, and for polystyrene it would be styrene. In a laboratory, 100 gram of plastic waste sample is pyrolyzed in a batch reactor, which weighs 250 grams. Weight of collected oil is 35 gram. Final weight of reactor is 255 grams. Calculate the yield of gas, liquid, and solid fractions.
Answer D.
So yeah, so obviously the solid you can get it basically directly. So the reactor weight is increased by 5 grams. So for 100 gram of waste plastic is 5% of solid, and the liquid weight is simply the weight of liquid is given as 35 grams. So 35% of liquid and the rest is gas. Which of the following statement is not true about batch reactor or semi-batch reactor? Easy to control parameters, simple design, easy for large scale operation, higher labor cost per batch.
C. Third.
So yeah, it's obviously not easy for large scale operation. Which of the following reactor can be used for pyrolysis of plastic waste?
All of the above.
Yeah. So all of the above can be used for pyrolysis. You have to identify the type of reactor for pyrolysis.
A. Option A.
It's a conical spouted bed reactor. Then in this week's lecture, there are typical composition of gas produced through different routes, processes for removal of unwanted elements from gas, and then different particulate removal techniques and gas molecule removal techniques. These were all discussed. A MSW based power plant is emitting 36,000 meter cube per hour flue gas. It is proposed to install an ESP with collection efficiency 95.5%. Calculate the total area of collection electrodes. So the efficiency we can get it by this particular formula, 1 minus e to the power minus 0.13 AC by Q. So here efficiency is given, but we don't know the AC means area. So Q is given, uh, this particular flue gas rate, which is 36,000 divided by, you have to calculate it in the seconds, divided by 3600, so it's 10 meter cube per second, and efficiency given 95.5% means 0.955. So just put the values and then get it. The area is coming around, by my calculation, around 238. So the nearest value is given as per their question, around 206. Then we come to the 6th week lectures. These were discussed for the biological routes for waste to energy conversion, anaerobic digestion for biogas production, mechanism of anaerobic digestion, microorganisms for anaerobic digestion, pathways, different pretreatment techniques for this, the flow sheet and types of anaerobic digestion process, the kinetics, then different anaerobic digester and their types, and our further basic operations and two-step digester, like that. Which of the following is not a primary product of anaerobic digestion? Hydrogen, biofertilizer, usable
Hydrogen.
water.
Hydrogen.
The correct answer is bio oil. So bio oil, you get it via the pyrolysis, but it's not a primary product of the anaerobic digestion. You have to match the following major gas component with their appropriate percentage: carbon dioxide, methane, nitrogen, oxygen.
A.
Yeah, so biogas component involve this kind of composition. Methane we have about 50 to 75%, CO2 about 25 to 50%, nitrogen 0 to 10%, hydrogen 0 to 1%, and oxygen 0 to 1%. Generally, dash is the rate limiting step involved in methane formation. So methanogenesis is normally the rate limiting step for methane production. In anaerobic digestion, the presence of lignin decreases the rate of acidogenesis, acetogenesis, methanogenesis, hydrolysis. So hydrolysis is the correct answer. The presence of lignin decreases the rate of hydrolysis. The theoretical substrate conversion rate per unit reactor volume can be estimated as these are the four options for the formula. So the correct answer is the theoretical substrate conversion is S naught into nu max theta minus 1 minus Ks divided by theta into nu max theta minus 1. Okay. S naught is the substrate concentration in feed, nu max is the maximum specific growth rate, and Ks is the saturation constant. You have to match the following waste with the typical methane content. Wastes, grass, corn silage, poultry waste, and their typical methane content percentage. So these are the list of different waste and their typical methane content. So you can check that grass have 84% methane content, corn silage have 52%, and poultry waste has 68%. Then the other lecture it detailed about the energy related to cells and fuel cell theory, microbial fuel cell, its working principle, mechanism, design of microbial fuel cell, different microorganisms for this, the different parameters which affect the performance of MFC, current and voltage calculation, and types of microbial fuel cell and some efforts for improvement. Galvanic cell is used to convert what type of energy to what type of energy. So galvanic cell is basically converts chemical energy to electrical energy. Then mm, this week's final lecture it discussed about the fermentation technique, fermentation and energy production, production of ethanol from three different feedstocks and their pre-processing steps, the treatments, detoxification and hydrolysis, ethanol production through gasification route, butanol production from lignocellulosic biomass. So DAS is a metabolic process which converts sugars to acids, gases or alcohol. So fermentation obviously is a metabolic process which converts sugar to acids, gases and alcohols. Depending on the operating condition and strain of the yeast used in fermented mash can attain a level of around dash percentage of ethanol concentration. So the correct answer is 4 to 10 percentage. Okay. Then we come to the 7th week lectures. The 7th week lectures further the fermentation techniques, fermentation, microorganisms and product recovery, ethanol production through gasification route, butanol production from lignocellulosic biomass. These were discussed. The maximum theoretical ethanol yield can be calculated by so the correct answer is the maximum theoretical ethanol yield equals to ethanol produced in reactor divided by initial sugar in reactor into 0.511 into 100. Biological route uses which bacteria for the production of ethanol from lignocellulosic biomass. Clostridium jungdali is the correct answer for the production of ethanol from lignocellulosic biomass. So in a high rate biogas plant, food waste is anaerobically digested to produce biogas. Slurry contains 8% of solid food grains. Elemental composition of food grains is given. 80% of food grain converted to biogas, and all hydrogen converted forms methane. Slurry flow rate is also given to calculate the rate of the biogas production. So flow rate of slurry is given as 4500 liter, and 8% of solid food grains is there, so it's coming around 360 kgs, and the density of slurry is assumed as 1 kg per liter, and from this you can get the carbon present, hydrogen present, oxygen present, because we have given the elemental composition CHON present from it. And then you 80% of food grain converted to biogas. So from in individual element you can get how much carbon is converted, how much hydrogen is converted. All the hydrogen is converted to methane, so you can go back calculate and then take this as the total methane production quantity. From that you can get the carbon for methane production, and the obviously the rest of them will be used for fuel production. Okay, from that you can get the CO2 produced. So methane production you have got, CO2 production you have got, just sum them up and you will get the rate of biogas production. Another problem, during pre-treatment 50% of the lignocellulosic biomass is converted to monosaccharides and disaccharides in a mass ratio of 6:4. The monosaccharides produce 510 grams of ethanol, disaccharides produce 540 grams of ethanol per kg. Assume the same mole ratio of both monosaccharide and disaccharides as 1:1. Calculate the yield of ethanol. So you see this solution. We have taken a 100 kg basis of lignocellulosic biomass. So 50% is converted to monosaccharides and 50% to disaccharides. So each of them converted to 50 kgs, and their ratio is given as 6:4. So among the 50 kgs, 30 kg is monosaccharide and 20 kg is the disaccharides. From that you can get like 1 kg of monosaccharide produces is given 510 grams. From that you can just multiply it with the 30 kg. So 30 kg will give us 15.3 kg of ethanol. Similarly, ethanol produced from disaccharide will be 10.8 kg. So total ethanol you get, and with respect to sugar, so we have got for 50 kgs of original monosaccharide and disaccharide. So with respect to 50 kgs, we are getting about 522 grams of ethanol per kg of sugar. And then if you further go back to with respect to lignocellulosic biomass, we have taken originally 100 kg of lignocellulosic biomass. getting 26.1 kg of ethanol, so 26.1 by 100, so 0.261 kg of ethanol, or 261 grams of ethanol per kg of lignocellulosic biomass. That is the yield. Then moving ahead, further lecture discussed about transesterification for biodiesel production. What is basically transesterification? Different organic wastes which are used for transesterification reaction. Production of bio-oil from oil seeds and its major composition. Need of upgradation of bio-oil to biodiesel, its properties, and then general steps of upgradation and production routes. During the transesterification process, alcohol such as methanol reacts with the dash to form fatty acid alkyl esters and glycerol. So during the process of transesterification, an alcohol such as methanol, it reacts with the triglyceride oils contained in plant oils, animal fats, or recycled greases to form fatty acid alkyl esters, or which is known as biodiesel and glycerin. The conversion of free fatty acids can be determined from the following equation. What is the correct answer?
A.
So A is the correct answer. Conversion is initial acid value minus the final, or at time t acid value divided by initial acid value. The acid value is calculated as, what is the correct formula for acid value determination?
First one.
So yeah, 56.1 into V into C by M. V is the volume of KOH employed in for titration. C is the concentration of KOH used for titration, and small m is the mass of the sample. In transesterification process, plant oil which contains less than how much percentage of free fatty acids is filtered and then pre-processed. So correct answer is 4. Plant oil which contains less than 4% free fatty acid is first filtered and then pre-processed. Select the factor which affect the performance of transesterification process. So all of these are correct. So the factors affect the transesterification process are reaction temperature, time, free fatty acid content, water content, types of alcohols, etc. etc. All of these are the important parameters. You have to match the following feedstocks with their catalyst for the production of biodiesel. So sunflower oil upgraded by strontium oxide as catalyst, soybean oil as potassium carbonate and TiO2, and coconut oil were embellished 15 and sulfonated ion exchange regime. Then we come to the final week, which is the last week of the lectures. We discussed about the algal cultivation, why algal cultivation, algal metabolism and synthesis of fat and protein, classification of algae, lipid content in algal cell, algal lipids and biooil quality, conditions influencing algal lipid quality and quantity, enhanced lipid accumulation, reactor systems, harvesting of algal biomass, and treatment of wastewater. Which of the following is not an example of saturated fatty acids? Capric, stearic, myristic, oleic.
Oleic.
Oleic acid is not an example of saturated fatty acid, it's the unsaturated fatty acid. 50 gram of waste cooking oil is fully dissolved in some amount of neutralized ethanol by heating and titrated with N by 10 KOH solution using phenolphthalein indicator. Titer value is 100 ml. Determine the acid value of oil. So this was the acid value formula discussed. 56.1 into V into C by M. So to put the values. Okay. So 100 ml titer value. C is the concentration of KOH is N by 10 means 0.1 divided by weight of the sample is 50 grams. So just put the values and you get about 11.22 mg of KOH per gram of bio oil. That's the acid value of this particular oil. A 200 ml of bio oil sample is reacted with 81 gram iodide monochloride. After reaction, iodide potassium iodide is added in it and liberated iodine is titrated with sodium thiosulfate. Zero point 0.2 moles of sodium thiosulfate consumed. So have to determine the iodine value of the oil. So You can see from this reaction about 2 moles of thiosulfate it reacts with 1 mole of iodine. So zero point 0.2 mole thiosulfate will be reacting with 0.1 mole of iodine, which is equals to about 25.38 grams of iodine. And in the original solution, 81 gram of uh, iodine is present. So 81 into 126.9 divided by 162.35. Okay, just go for the back calculation for this thing and you get it. Original iodine present is as the 63.31 grams and 25.38 grams you get from this particular equation. So iodine used is, this is the original solution and this is the iodine reacted. So iodine now you are getting in the product. So iodine used will be the subtraction 63.31 minus 25.38 is 37.93. Which of the following is not a type of closed system photobioreactor? Vertical tubular, horizontal tubular, plastic bag systems, raceway pond. So raceway pond is a type of open photobioreactor. It's not a type of closed system photobioreactor. Flat panel photobioreactor typically have a width of dash centimeters 5.5, 3.2, 8.5, 10.5. So for open pond type photobioreactor, the depth is the typical dimension, which is about 1 to 15 centimeters. For the horizontal tubular photobioreactor, it's the internal tube dia about 2.5 centimeters. For vertical column is a 2.6 centimeter column internal dia, and for flat panel, it's the width, which is the typical dimension, is about 3.2 centimeters. Among the following algae harvest method, which one has the relatively low cost? Gravity sedimentation is the correct answer. So gravity sedimentation have a relatively low cost. On the other hand, inorganic chemical flocculation, polyelectrolyte flocculation, flotation, these are all having high costs. Then the final part, the lectures about the biodiesel as an important option for energy production from algal biomass, bio-oil production from algal biomass, conversion of algal oil to biodiesel, types of conversion processes, factors which affect this kind of biodiesel production, quality parameters, upgradation using heterogeneous and homogeneous catalysts, challenges, biojet fuels, and typical research status on algae to oil. Then final few questions remaining. Which of the following catalyst trans-esterification process used for biodiesel production? Homogeneous base catalyst, homogeneous acid catalyst, enzyme catalyst, all of the above.
All of the above.
Yeah, so homogeneous base catalyzed, homogeneous acid catalyzed, and similarly heterogeneous catalyzed base and acid, enzyme. So all these type of different catalyst families are used for the biodiesel production. Select the factor which affect the biodiesel yield.
All of the above.
So oil temperature, reaction temperature, catalyst type and concentration, the ratio of alcohol to oil, intensity of mixing, reaction purity. These are all the important parameters which affect the biodiesel yield. Which of the following statement is not true about microwave technology, assisted catalyzed transesterification?
The energy requirement is less.
Which one is not true?
Oh, scale up is not supposed to be so easy, kind of.
Yeah. So the scale up is actually difficult for microwave, but energy requirement is actually less. So which of the following is not a type of homogeneous catalyst used for the algal oil upgradation to biodiesel?
The CaO, the calcium oxide supported on the aluminum oxide.
So yeah, it's a type of heterogeneous catalyst. Rest of the others are the homogeneous catalyst because they get dissolved in the solution. Yeah. So that's all from my side. A lot of questions were discussed. Thank you for joining. If you need
So
to,
can we still continue
yeah,
to talk after you terminate the recording, or
yeah, yeah.
okay? So once you stop the recording, please let me know.
So stop today's class here. Anybody has anything to ask or will disperse?
So my question was regarding how do we continue? I'm very impressed with this Swayam portal and all that, but that has nothing to do with this specific coursework. So I just thought maybe if we can stop the recording and then we can talk.